Welcome to the DIY Honda Garage channel. The Honda Accord 2023 Plus may store DTC P0617, indicating a problem with the starter cut relay 1 control circuit where the voltage is too high. The engine control module, ECM, often referred to as the powertrain control module, PCM, monitors various circuits including the starter cut relay. The starter cut relay is crucial for managing the starting system's function by allowing or disabling current to the starter motor. When the starter circuit is engaged, the PCM expects a certain voltage reading. If this reading is higher than anticipated, it assumes there is an abnormality and triggers this diagnostic trouble code. Understanding the relationship between the PCM and the starter cut relay will guide any repair process effectively. The starter cut relay 1 plays a pivotal role in controlling the flow of power to the starter motor when the ignition is activated. Its location is typically situated on or near the relay circuit board, making it integral to the starting system. The PCM, or powertrain control module, continuously monitors input signals from various components, including the starter cut relay, to ensure proper engine function. During the engine start process, if the PCM detects a return signal from the starter cut relay that indicates high voltage, it will recognize this as an abnormal condition. This triggers DTC P0617, alerting the technician to an issue that requires investigation. In terms of functionality, the PCM's operation in evaluating the signals is critical for diagnosing the root cause accurately. There are several possible causes for DTC P0617. First and foremost, a shorted wire in the control circuit could lead to a high voltage signal that confuses the PCM. This could occur due to physical damage, wear, or incorrect wiring. Second, if the PCM itself is malfunctioning, it may mistakenly interpret normal voltage as high voltage due to internal faults. Additionally, problems with the relay circuit board, where connections may be corroded or faulty, can contribute to abnormal signals being sent to the PCM. Each of these potential issues needs to be addressed methodically to pinpoint the exact reason for the stored DTC. When DTC P0617 is present, the most noticeable symptom is that the engine may fail to start. This is directly linked to the malfunctioning starter cut relay, which disrupts the power necessary for the starter motor's activation. Additionally, the diagnostics warning light will often illuminate on the dashboard, prompting the driver to investigate further. Technicians may also observe abnormal relay signals during testing, indicating a potential issue within the starter cut relay or the wiring circuit. By recognizing these symptoms early, repairs can be undertaken more swiftly, potentially avoiding further damage. The first step in troubleshooting DTC P0617 is to attempt to start the engine. This initial action helps to confirm if the issue is indeed present or if it might have been a sporadic fault. If the engine cranks or starts, it may indicate a transient issue. However, if there's no response or unusual behavior, this strengthens the case for a persistent problem with the starter cut relay or circuit. It's vital to document any observed behavior or diagnostic lights that activate during this process. Any changes in symptom presentation between attempts may direct the technician towards a more focused inspection. Even periodic reports of starting issues may align with the high voltage indication of the code. In the second troubleshooting step, you'll need to disconnect both the PCM connector A, which typically has 72 pins, and the relay circuit board connector A, usually with 18 pins. This step ensures that you can examine both the control circuit and the PCM more thoroughly. Before disconnecting the PCM, always remember to jump the SCS line using the HDS tool and allow for a waiting period of over 1 minute. This ensures proper discharge of any residual voltage. preventing potential harm to the module or inaccurate readings. Safety is paramount, and proper disconnection techniques will aid in effective diagnostics. Make sure to keep track of all connectors and their specific locations for reinstatement. At this stage in the troubleshooting procedure, you will conduct a visual and physical inspection for shorted wires in the circuit, particularly focusing on the ST-cut RLY1CL- wire. This inspection should be methodical. First, check for any obvious damage to insulation, frame, or contact with metal surfaces that might lead to a short. Pay close attention to connectivity and continuity of the wires. Use a multimeter to check for appropriate voltage readings in various conditions. A reading that indicates the wire is shorted to power when the ignition is on warrants immediate attention, as this could directly correlate to the high voltage condition described by DTC P0617. Ensure all findings are documented for reference in determining if further actions are necessary. Once you have checked for shorted wires, if everything appears normal, the next step is to evaluate the condition of the PCM itself. Since the PCM processes signals from the starter cut relay, any malfunction in the module could result in a false diagnosis, indicating high voltage where none exists. This step may involve checking for software updates or reprogramming procedures as outlined in vehicle-specific guidelines. Using diagnostic software will provide insights into the operational status of the PCM. If internal faults are detected, replacing or reprogramming the PCM may be necessary. It's key to understand that PCM issues can be complex, and thorough evaluation will lead to more accurate repairs. Once repairs are completed based on the previous steps, it's crucial to perform final checks to confirm the effectiveness of the intervention. This would involve ensuring all connectors are securely fastened and any replaced components are being monitored for operation. Additionally, troubleshooting any remaining circuits related to the starter cut relay and verifying operational status can ensure no further issues persist. After this, clear DTCs using diagnostic tools and retest the vehicle to see if the error reappears. Monitoring the vehicle's behavior during this phase is essential to ensure that the repair has resolved the issue without introducing new complications. Verifying the repair solidity will assure the safety and reliability of the vehicle. Preventive maintenance plays a vital role in a vehicle's durability, especially concerning the starter cut relay and associated circuits. Regular inspection of wiring systems will help identify wear or damage before it leads to significant faults like those reflected by DTC P0617. It's important to check connector integrity, ensuring that no corrosion or loose connections exist that could impact performance. Additionally, monitoring the vehicle's electrical systems regularly will assist in early detection of potential problems. By practicing vigilance in preventative maintenance, the risk of future issues can be notably reduced, fortifying overall vehicle responsiveness and safety. In summary, understanding DTC P0617 and its implications is critical for effective completion of repairs in a Honda Accord 2023 Plus. Identifying root causes, including potential shorted wires and PCM conditions, allows technicians to target their efforts efficiently. Following each troubleshooting step methodically will lead to an accurate diagnosis and support timely repairs. Furthermore, implementing preventive maintenance will promote the longevity of the starter cut relay and associated systems, thus avoiding unexpected challenges in the future. This comprehensive approach will ensure that the vehicle operates optimally and maintains the reliability expected in a Honda vehicle. Please like and subscribe to the channel. See you next time.